Alright, so welcome to MathsTronics STEM TV. Alright, so today it's going to be an example of electronics automation. Electronics automation using using software to control hardware devices. And of course, so we will be using software to control hardware devices. So for example, in this example, we have 3 motors, and then we have 3 LEDs. LED stands for light emitting diodes. So these are my resistors, and my resistors is going to control the amount of current that is flowing through to my devices. So I have a resistor connected on motor 1, another resistor connected on motor 2, another resistor on motor 3, and of course the resistors connected to my LEDs are needed. And I'm going to drill down deeper to show you why these these resistances are needed. Because my LEDs typically operate on 1.8 volts and 20 milliamps. So current in excess of 20 milliamps will, of course, blow my LEDs. So these resistors are very, very important. So all my one side of my resistors are all connected to ground. And this ground is connected to the ground of my Arduino. Alright, so this ground is connected to my ground of my Arduino. If it is not, I'm going to make that ground connection. So here is ground. Alright, so let me make that ground connection. So I'm going to take an Arduino ground here, and then I'm going to connect my LEDs to ground. I'm going to change the color of the wire to black as well. Alright. So I now have a ground connection. So that's my ground connection. So let's change this to black. Alright, so everywhere I see a black wire, I know that's going to ground. Everywhere I see a red wire, I know that it's going to a voltage source. So on my Arduino board, I have from pin 0, pin 1, all the way up to pin 13. And of course on these pins, I can place either 0 volts or 5 volts on these pins. Alright, so that's the concept. And so one of the early ideas that we just want to show, because we're going to start from a fundamental level, but one of the early ideas I want to show is how we can use a mathematical formula. For example, this one. So this is just a mathematical formula that says you are multiplying 2 quantities. Alright, so this is actually, for example, lambda, which is decay constant, versus n, which is the number of radioactive particles, for argument's sake. So if I want to calculate the activity A is just going to be equal to lambda multiplied by n. And so for my coding, what I want to show is if the student inputs the right answer here, where we have input answer, alright, then now what will happen is a series of things will happen. So that will allow us to activate the motors, and that will allow us to activate the LEDs as well. If the answer is wrong, then the LEDs and the motors will not be activated. Alright, and of course that is going to be the rationale behind the code. So the whole idea was making physics fun, so that was the concept, and we have it as edutainment. And of course, this formula, A is equal to negative L times N, is a formula that is in physics. Alright, so activity is just decay constant times number of radioactive particles. And of course, it could have been used for any 2 numbers being multiplied together. And of course, we're going to use different formulas to control different aspects of our circuits, and that is the ideal. So I'm just going to briefly go through the code. So here, for float, int equal to negative 200. So the student or the teacher will put in their answer here. And of course, we're going to be calculating something. So we have to declare A as a floating point number, because it's possible to get a decimal value. And then of course, lambda and n. So lambda is going to be a number that the student will put in as well, and n, another number that the students will put in. The computer will compute the activity, and if the computed value is equal to the answer, which is A and S, that will be placed up here, then what happens is a sequence of things will happen. All right, so we will be turning on lights, and then we're going to be turning on motors, and then we're going to notice that items connected on pins 8 and 9 will be off. Pins 7, 8, and 9 will be off, and of course we can vary this. All right, so we will make some modifications. All right, so we're going to be doing some experimentation, and we will be making some modifications to see what's happening. So if we start the simulation, all right, so I think the student would have inputted the right answer. So if I multiply 10 times 20, I will get 200, and in the formula there was a negative. So if I say negative 200 is the answer, then that result activates my circuit. So here we're showing that mathematical formulas can actually control real-world devices. All right, so we are using our mathematical formulas as like an algorithm to control. And so these are different activities that the students and the teachers can use in class to just show the relevance of mathematics and show the relevance of different physics formulas as well. And of course, we're going to be going deeper, all right, by looking at the entire coding in detail. So this is really still part of the introduction to KRW-Tronics 10 TV. So how we set up the pins will be discussed, and of course how we send voltage to the different pins as well. So what we're crafting here is really the concept of educational engineering. So basically we're showing how theoretical formulas can be used in computer integrated development environments and circuit simulation tools like these in order to control them, and also in that process we can show the student how we can link theory and application. All right, so we will be going a little bit deeper, all right, in just a moment. Okay, so we are back. So for this application, so we have a simple formula. Activity is equal to the decay constant times the number of radioactive particles. All right, the student will input their answer here, and of course A, L, and N. So these are the different symbols in the formula. All right, and the formula is illustrated here that I've highlighted. So here A is equal to negative L times N, a product. All right, so if our inputs are 10 and 20, where 10 is the decay constant per second, N is the number of undecayed radioactive nuclei. So if we put in these two values, then our result will be negative 200. And if we're not sure, we can click on the serial monitor, and what we see is that the answer, all right, the computation for A is negative 200. And you will ask the question, how do you know that? And of course, how I know that is because right here at the end of the code, I have a line of code that says serial.println A. So I'm actually printing out the value that is placed in this memory location A, or this is variable A, and it's negative 200. So since the answer that the students would have computed in their book is negative 200, and the answer computed by our algorithm here is also negative 200, then this line of code will be run. So I'll have digital write 3, high. This means that I'm putting 5 volts on pin 3. And then, of course, that 5 volts is going to be on pin 3 only for a short time. All right, and that's going to be half of a second. So 500, delay 500 means half of a second, because the delay function is measured in units of milliseconds. So 1000 milliseconds gives us 1 second, 2000 milliseconds gives us 2 seconds, etc. So digital write 3, low means I'm putting 0 volts on pin 3, and that's for the same, all right, half of a second. And then now I'm going to be turning on some LEDs. So digital write, 4 means I'm putting 5 volts on pin 4. Digital write 5, high means I'm putting 5 volts on pin 5. Digital write 6 means I'm putting 5 volts on pin 6. And of course, everywhere I see a high, these LEDs will be on. and of course on pin 7, 8, and 9. So I can look to see what is connected on pin 7, 8, and 9. Those will be off. Alright, so that's the concept. And these are the instructions on the void loop. So loop means that this is going to occur over and over and over again. So by the time you would have written this first example, what you would see is that this will happen over and over and over again. So if I want this to happen for a set number of times, as we will go into that deeper down in our STEM talk and our STEM series, we will use a for loop and a while loop as well. So for this number of rounds, you're going to do this while a certain quantity is that. So when we reach that condition, we exit the program as well. And of course, I will be talking about that in great detail. But I want to focus on now is how cool it is. So if I should stop the simulation and if I should put 20 here, alright, so if I should put 20 there, so the answer is now -20 that we computed in our book. Alright, the computer will still be computing -200. We can start the simulation to see if, alright, our automation works. So right now, as we can see, our circuit is off, nothing is happening, and that is because the answer that we have inputted in our computer is not the same as the one computed for the variable A. Alright, so that's the idea. So if I stop the simulation and I go back, and I said, okay, it's not 20, I put 200, alright, and then I start the simulation. Okay, so we are back. So this is an example to show how different mathematical formulas can control hardware devices. So there are other devices that we will have. So we will design a robot with the L293 or the L298 motor drivers, and of course we will then write instructions, alright, using formulas. So if, for example, if the formula, if the pressure is equal to 100 pascals, for example, we can allow fans to be on and lights to be off. So we are going to organize those type of concepts. What we expect is, for example, when a teacher is teaching or somebody is just exploring with physics, they can say, okay, I would have done pressure, alright, pressure is equal to force over area. I would have done radioactivity, activity is equal to decay constant times number of radioactive particles. Let's see how we can use this in a real world context. So this is the purpose of STEM. That stands for science, technology, engineering, and math. So it's an interdisciplinary approach that we're bringing here. So by learning about physics, you're glancing at a little computer science, and you're glancing at a little industrial experience as well. And of course, there are going to be some critical thinking activities that we will do. So the type of thinking here is to really bring it beyond what you will be, say, learning in school from a critical thinking standpoint. So that, of course, persons can be good problem solvers in the world of work and, of course, in the world of applied sciences and STEM, if one chooses that. So on the void setup, we have a line of code that says serial.begin 9600. That sets the baud rate. All right, and of course, I'm going to dive down into this a little bit deeper. And of course, if I want to send voltage on certain pins, I will have to set up the pins. So pin mode 3, output. I'm configuring pin 3 to be an output pin. Pin mode 4, output. I'm configuring pin 4 to be an output pin. Pin 8, pin 5, pin 6, all to be output pins. And notice on my output pins, I have devices that are connected on my output pins. Alright, so that's the concept. So devices are connected on my output pins. And of course, what I'm going to do, there are going to be smaller circuits that I'm going to be designing. And on these smaller circuits, what's going to happen is that we will drill down to actually do coding. So right now, I'm actually doing application of the coding, all right, and how we can actually use it in the classroom, or how we can use it in a real-life context to kind of allow us to appreciate certain things more. So this is our second video on the KW Electronics STEAM TV channel preview. So until then,